Hello and welcome to the Stars of Physics. In today's video, we shall see Ohm's law, its theory, experiment, observations, calculations and results, all these things in detail. In this video, we shall discuss Ohm's law, theory, experiment, calculations and results. So, consider a circuit as shown here. So in this circuit we have a variable power supply, which is a DC power supply, and resistance capital R is connected in series with this DC power supply. Then current I will flow through this circuit. To measure this current, we have to connect an ammeter which will measure the current flowing through this resistance capital R. And we have to connect a voltmeter across this resistance to measure the voltage drop across this resistance. Then according to Ohm's law, we have V is directly proportional to I. That means voltage across this resistance is directly proportional to current flowing through this resistance. So if the proportionality constant, we will take it as a capital R. Therefore, we get V is equal to capital I into R. So here, if we increase R, then I will decrease. And if we decrease R, then I will increase. So to visualize this, say when we can visualize this with the help of this animation. If we increase R value, then what will happen? Current value will decrease. So if R increases, current value will decrease. And on the other hand, if we decrease capital R value, then the current value will increase. Now, to do the experimental verification of this law, V is equal to IR, we have to connect the circuit as shown in our first slide, and we have to note down voltage and current readings. And after noting down voltage and current readings, we have to plot a graph of voltage in volts versus current in ampere. That graph, we have to find out slope of that graph to get the resistance value. So that we shall see in the experimental section. Welcome to the experimental section. Here I am going to explain you Ohm's law. The circuit diagram for Ohm's law is shown over here. So we have a 9-volt battery here, and to 9-volt battery we have connected in series with that a resistance, and then in series with that we have connected a milliammeter for current measurement, and in series with that we have connected a pot which is a variable resistance, and then again it is connected back to the 9-volt battery's another terminal. And in parallel to this resistance, we have connected a voltmeter. The experimental setup is shown over here with the same as per the same diagram. Now we can vary the voltages and current with the help of this pot. See, I will vary this pot to get different voltages and currents here in these two meters. So this is multimeter, which is used as a voltmeter in this case, because we are keeping it on the DC voltage measurement, and this is the milliammeter, so which is 0 to 500 milliampere range. So you can just see that how the different readings are going to there. See, I will just vary this pot now, and you can see that voltage is increasing, and along with the voltage, current is also slightly increasing. So like this we can get different readings here. See, there is sudden increase. Okay, so 1 volt, 2 volt, 3 volt, like that we can go up to 6 volt in this case. So here what we have to do is we have to vary this pot, and by varying this pot we have to measure the different voltage and current readings. Like for say 0 volt, what is the current? It will be 0 milliampere. Okay, and I will write down it here, milliampere, and this is in the volts. Then for 1 volt, what is the value of current? We have to note down. Then for 2 volt, what is the value of current? 3 volt, what is the value of current? 4 volt, 5 volt and 6 volt. So these current readings we have to note down by varying these values. Mental part, I hope that you understand this, and for recording this I am very much thankful to Sandeep sir and Dake sir in arranging this setup. So from the above experimental section, I note down these readings for voltage and current. We shall plot a graph of this. So to plotting this graph, I have to just select this and then go to insert, and then I will go to this XY scattered, and I will plot line as well as these points, both of them. Now this will give us on y-axis we have voltage and on x-axis we have current. Now we want to find out slope of this graph. You have to label all these things, of course. Now then we have to find out slope of this graph. So I will just go to right click this and go to trade line. And then from trade line, I will fit it into a straight line. Yeah, this one. So this will show the this will fit this into a straight line. Y is equal to mx plus c type of line. So here I will just magnify this for you. Yeah, you can see here we get y is equal to 815.07 into x plus 0.089. So this slope of this graph is 815 is the value of the slope of this particular graph, and therefore the value of resistance is nothing but 815 ohm. Now we have just fitted here it into a straight. So we have, according to Ohm's law, we have V is equal to I into R. Now here we have fitted it into a straight line. So we get Y is equal to mx plus C. Actually, ideally this C should be 0 in case of Ohm's law. And then this m, small m, is nothing but the slope of the graph, and this slope of the graph is nothing but the value of resistance, which in our case it is 815.07. so it is approximately, we can say 815 ohm is the value of the resistance we obtained here by using Ohm's law experiment. Do like, subscribe, share, comment and press the bell icon. Thank you very much.